Number 34. All right, so variables looks like we've got cakes and cookies. All right, our goal is to maximize profits. And there's one trick on this one. Your book, for some reason, switched the order of the profit numbers given at the end there. It's 20 per cookies and 30 per cakes, so they switched the order of cakes and cookies. So just make sure you watch that. So your profit's actually going to be 30x plus 20y if you do x as cakes and y as cookies. The constraints are on the time available in the oven and the decorating room, not the cakes and cookies. So try setting up a chart for this one and do the time in the oven, time in the decorating room. All right, how much time is needed for a batch of cake, how much time is needed for a batch of cookies, and then realize that we would be multiplying that by x and y if you've got multiple batches of cake or cookies. Okay, and then look for some constraints. How many hours are available in the oven? How many hours are available in the decorating room? This one does have fractions, so you might want to look at the general hints for looking for intersection points of lines if they are fractions. I would say it's this number here, the decorating, that's going to be kind of a messy fraction if you try to round this, right, 2/3. So make sure when you write your constraint, do leave it as a fraction, do leave it as 2/3, but then of course when you graph, it would be fine to estimate where that is on the graph. Number 35. This one is the only one that really doesn't deal with money. This one's interesting. We're trying to maximize the number of people aided in a situation where we have earthquake victims. All right, so we're looking for to maximize P. In this case, P is for people, the number of people aided. Your variables here, we're finding how many medical kits and water containers should be sent. All right, and then the constraints happen to be on volume and pounds that a plane can carry. All right, so we would want to set up a chart again. All right, we've got med kits and water, and then we have the volume of each of those, and then also the weight. All right, and then we know that the plane can only carry 80,000 pounds, so the combined weight's got to stay below 80,000. And the combined volume, the plane can only hold 6,000 cubic feet. All right, so you would want to go back and fill in how many cubic feet is each med kit and how many cubic feet is each container of water, and then what's the weight for each of those things. All right, and go back and multiply by x and by y. And then, of course, always your given ones, didn't mention this every time, but always x and y have to be greater than or equal to 0. And I think that should help writing your people function. Just think about how many people each med kit and each kit of water can help.